So our first talk is by Brian Schilder, Our Workflows, Taming the Wild West of Our Packages.
All right, thanks everyone for waiting. And I'm going to be presenting some of our lab's work on our workflows. I'm a PhD student at Imperial College London, and I'm in the group of Dr. Nathan Skeen. So let's start with a simple question. How many R packages are there? A couple thousand, a couple hundred? Well, actually, it's upwards of at least over 50,000 of the ones that are publicly accessible. So that's a lot. So how are these packages distributed to users? Well, if you gather data across all repos, including rOpenSci, CRAN, Bioconductor, rForge, and GitHub, you find that over 50% of all R packages are now exclusively distributed through GitHub. And this is in large part due to the ability to install directly from GitHub with the remotes package and the install GitHub function. But don't get me wrong, I love GitHub. It's awesome, and I think everyone should use it, or at least some kind of version control system like it. But there's some things that you're probably aware of, namely that just because code is on GitHub doesn't necessarily mean that it's going to be installable, that it works, or that it's going to work in the future. So how does this play out in the real world? So let's take the example of the R package foobar. It was just published by Eastwood et al. In the esteemed and reputable journal Signatures. A completely hypothetical thing. And now let's say you see this publication and think this is exactly what I need for my project. It foos all the bars and it outperforms all previous tools. However, when you go to do it and you actually try to run this, you find there's some issues. First, you have some difficulties with installing it. So you go back and forth with developers to try and work that out. Eventually you get it installed, but you run to the next issue that there's very minimal or no documentation, and the examples they do provide don't really work as is. And finally, you get the package running on some example data, but you find it's throwing some cryptic errors when you actually go to run it on your data set. And this goes on for several weeks to months, and finally you decide you can't sink any more time into this, no matter how good the Signatures paper says it is. So this leaves us with an important question. With so many R packages out there, over half of which are now distributed only on GitHub, how do users assess which tools are going to work as advertised before they actually invest the time in it? Well, some options. We could convince everyone to submit their packages to CRAN, Bioconductor, and rOpenSci, but I think that's fairly unlikely and not necessarily appropriate for every package. We keep playing Russian roulette with GitHub-only packages, which includes the good, the bad, and the ugly. Or we as a community could provide tools to make continuous integration as easy and mutually beneficial as possible. And for those who don't know, continuous integration is essentially a framework in which developers can make a change to their software, push it to some repository, launch automated checks, and just continue this cycle so that they know that their package is working as intended. And fortunately, GitHub launched a native solution a couple of years ago called GitHub Actions. And it's gotten a lot of widespread usage. And this really is nice because you don't have to have any external services or anything. It's all free within GitHub. So let me first make a distinction between workflows and actions. It's kind of confusing, but it's an important one. So workflows are static YAML files, which you include in your GitHub repository when you push it. And they will basically list all of the things you want to do, install, check, whatever else. But there's no version control, doesn't provide any usage stats. and you have to duplicate those files within every repo for every user. This is in contrast to actions, which are basically centrally maintained versions of workflows. So you just call the action, and they're completely version controlled, and you do get some usage stats as far as who's actually implementing them. So just a quick timeline of what this has looked like in our development community. There's been some attempts to really capitalize on GitHub Actions within our packages. And this includes use this, which writes a series of separate workflow scripts to define the code checking tasks. You also have BIOC actions, which are a series of centrally maintained actions that are separate. And then BIOC this, which basically distributes a series of workflow scripts via an R package. And then finally, what I'll be focusing on today is our workflows, which merges many sub-actions into one action that is standardized and centrally maintained. Means that users never have to even touch the YAML scripts. And whenever there's a problem and it gets fixed by our team, it is immediately propagated to anyone who uses our action. So how does it actually work? Well, first you need an R package. If you have one already, great. You don't need to do anything. But if you are starting a new one, you can use template R, which is intended to basically automate a lot of the documentation processes by pulling information from the description and filling it throughout all the relevant markdown files, vignettes, things like that. If you have an R package that you've already created, you can add the R workflows short workflow script, which basically just calls the R workflows action. The only thing that you need to do is run the function use workflow with all the defaults, and it will automatically infer logical defaults and write everything for you. There's 24 different parameters you can change to change how it gets triggered, where it's launched, which platforms it's launched on. So it's very customizable, but it works right out of the box. And then finally, once you make your changes and push them to GitHub, your R workflows action gets automatically triggered and runs all of the things which I'm about to show you. So first of all, it creates virtual machines on 3 different machines: Linux, Mac, and Windows. It will install all the system dependencies, R dependencies. It will run CRAN and or bioconductor checks. It's up to you. And it will also run unit tests and give you code coverage reports. And let's say in this example, it doesn't run on the first try on Windows. There's a bug. Check out the bug. You fix it, make a push, and now it's running on all 3 platforms just fine. As a bonus, you get a lot of different things. You can automatically generate a Docker container with everything installed. It will push it to DockerHub, where people can then pull it without having the need to actually install any of the dependencies themselves. It will turn all of your Roxygen notes into a documentation website using package down, and then launch them in GitHub pages. And it'll give you all of these badges on your README, which will give you sort of a health report on your package. I'm going to just skip over this very quickly because I'm running out of time, but there's a lot of different parties that I think can benefit from this, including developers to run checks, even if you're on Bioconductor and CRAN, to make sure that things are working before you push upstream. Assess package health for users who are trying to figure out what package they should be using and making installation easy. And also for reviewers to also assess package health and make things easier to install and test, making it more likely that they're actually going to test it and not just take the writer's word for it, which can happen sometimes. People are starting to use it, even though I haven't really officially advertised it yet, and more than happy to take community feedback. Also provided some tutorials in collaboration with several other people in this group. In the future, we'd like to use more official sub-actions, have sort of meta actions to check the health of our action, promote this more through different mechanisms. I'm also making pull requests to high-impact repositories that are used a lot for different R packages so that it gets has a larger impact. And then finally, try to procure some long-term support from Bioconductor and the R core team, ideally. So thank you very much for your attention, and take any questions afterwards, I suppose.
Thanks, Brian. Just give me a minute. Let me figure out how to go to the next slide.